We're going to use calorimetry to find the enthalpy for a reaction. This one, magnesium and oxygen. But we're actually not going to react them directly. We're going to do other reactions and then use Hess's law to find the actual enthalpy of reaction 1. You can pause to see the equipment and indeed the procedure. There's a separate sheet you can look at from the website as well. And we're going to do calculations using the heat transfer equation to find this. The equipment we're going to use is a calorimeter. Going to put in 100 milliliters of 1 molar acid. We're going to assume that the heat is transferred as if it is 100 milliliters of water. And here we are looking at some of the actual lab activities, measuring 100 milliliters of the acid in a graduated cylinder. And our calorimeter is an insulated drinking cup. This one is styrofoam. You'll see a different type in a moment. It's going to have a lid. You're going to take the temperature every 30 seconds for 3 minutes, just of the acid to begin with, and then every 30 seconds after you add the magnesium. Here's 30 centimeters of magnesium being massed. Another example of transferring the liquid, but of course only measure it when you take the funnel out, which is going to happen in a moment. There we go, and you can get the actual volume. Hello. For the second reaction, we're going to look at magnesium oxide reacting with the 100 milliliters of 1 molar hydrochloric acid in order to get our 3 reactions to obtain our first reaction enthalpy. So here we're going to use 10 grams of magnesium oxide, and again measuring out the 100 milliliters of hydrochloric acid, and that's poured into our insulated calorimeter. And the first thing that we're going to do there is to again take the temperature every 30 seconds for 3 minutes to get our reactant measure. Then we put in our magnesium oxide and again take the temperature every 30 seconds for about 3 minutes. We're going on to do the calculation, and we're going to use the heat transfer equation, and we're going to need the temperature. And how do we determine what the temperature of the reaction is going to be? How much heat was given out? So you've got that baseline of the acid. It rises when you add the here magnesium oxide, and then once it's reached its peak, it starts cooling down again. So you add your line of best fit, you extrapolate it part of the way to the point where the magnesium ribbon or the magnesium oxide was added. That will be your temperature. Don't continue that line up to the y-axis. To get to the y-axis, just go along horizontally to get the temperature, maximum temperature, which would be obtained on mixing. So we're going to use heat given out is mass times specific heat capacity of water times the temperature. Also research the heat given out for hydrogen reacting with oxygen. I'm not going to do that reaction now. And then you're going to manipulate the sum of the 3 reactions, the 2 you've just worked out the enthalpies and the 1 that you're just researching. And thank you for the Washington International School and the students and science faculty there.